All right, welcome back to the meeting. And today we're gonna having chapter three. I'm sorry, chapter eight, part three, and then we'll be working on the exam two review and making sure that we are able to do so. What we're doing so far about the chapter, let me just pull them out real quick for that part. So I apologize for today because I have the laptop is not being able to turn off. Yeah. Okay, so now let's take a look at the chapter 8 and let's see how it's going to be. Okay. So this is chapter 8, part 3, and I upload this file on Blackboard. So what is this chapter about? So this chapter is basically asking us to select the required sample size. So why it is so important to select the required sample size? Because in statistics, okay, sometimes collecting a sample isn't easy. Okay? So we might need to do a lot into, and we might need to worry about the error barrel and so on and so forth. So for some statistic purpose, for some research that, for example, I don't want my error barrel to be more than 1% of the mean. Okay, so meaning that I want the error barrel to be balanced between that. So what's going on is we need to balance out between the E and then the N. So let's say I want my error bar to be less than 1%, okay, from the mean. And what is the required sample size? That how many samples do we have to collect from a population? So that will be the thing that we're going to be doing. Okay, so the thing is, we're gonna have two formulas for the error bar that we learned from chapter 8 part 1 and chapter 8 part 2. So the first one that we have is E equal to the Z times the population standard deviations over radical N. And the second form is basically more practical because that involving the t-score. So the t is somewhat better to estimate the population mean when the population standard deviation not known. So in other words, especially the t is better when we dealing with a small sample. So when we have a big sample, that's all right to use z or t. But what I'm saying is that when you only have to collect like a small sample, t score is always be a better way of doing it. So in other words, so let me just do that real quick. So let's say we're going to have the E equal to the Z times the sigma over radical N. So it is super important that we're going to pick the right sample and in order to control the error. So if you ask me, can we basically minimize the error bound? The answer is absolutely no. It's more like the balance out between the error and the N. So there's no way that we can reduce the standard deviations because the standard deviation will be coming from the intrinsic value of the data set. So in this case, the standard deviation should be fixed. So we cannot change the value, right? So if you collect a data set, when you change the value, this is basically bias. So we cannot change the data set value generally. So in other words, all we need to do was we're trying to either collect more sample size, right? So that we can you know, control the error bar, or we can control the confidence interval. But the confidence also based upon the research on a purpose. So let's say I only take 95% confidence, meaning that you might have 5% that things go wrong within the bow. So so meaning that we can't change the z or t either. So the t, so why we cannot use these forms? So you think of it, the t basically based upon two things. The one we call the confidence interval, and the other one we just call degree of freedom. So we learned from chapter 8 part B such that the degree of freedom would be equal to n minus 1, right? So the t-score also depends on n, right? So there are actually two things. So let's say I want to solve for n using the second form. That doesn't work because we cannot find the t-score given by the degree of freedom because we don't know how many samples should we collect. So the first step of the experiment is so for example, when we go back to the chapter 1 saying I want to collect the sample size using different techniques, but how many of them should we collect? Maybe 25, maybe 30, maybe 40, maybe 50. We don't know, right? So this chapter is basically helps us to understand how many samples should we collect based upon the error bar that we allow to contain, that we allow to have on the confidence interval. So in this case, though we can't solve for this one, so this is basically gone. So we can't do that. Okay, so for that part, we can't solve and using t distribution. So this is really important because we know the fact that t based upon uh, the degree of freedoms, right? So the confidence interval is how we set them up. This is not going to be a big deal, but what I'm saying is that the thing that we have right here is we only use the first form to solve for the end. So in other words, for example, for those of you who are learning the algebraic, so we're going to multiply both sides with radical n. And so we do the same thing for this part. And we're going to cross out this and that, and then we divide both sides by e in this case, so we can just separate them. Okay, so we divide both sides by e in order to solve for that variable, and then we're going to have this part, right? So, and after that, we're going to have the radical n equal to a z times the standard deviations over e. So finally, that we're going to square them so in order to get rid of the radicand. So I believe that this is what we learned from MTH. But if you don't know it, that's perfectly okay because we need the formula to solve the problem. So meaning that we're going to take the square, and finally that we're going to come up with the n. In this case, would be equal to the z times sigma over radical over e square. Okay. So again, that we can't use the t because the t also depends on the n. So we cannot solve for them. We cannot solve both of them at the same time. In other words, the n, the sample size, is basically corresponding to the standard deviation proportional to standard deviation, but disproportional to error bar. That's pretty straightforward because the more sample that we collected, the better estimation that we're going to have, and the less error that we committed to. So this is very important that we understand the strategy in order to solve a problem. So in other words, again, that the thing that we can only solve for the first form is that would be the things. And on the other hand, that we're going to have is how we're going to apply them. So how we're going to apply them in the real situations where when we have a certain problem. Remember that when the questions asking us to do the sample size, it's always better to use the standard deviation with the sigma because we're definitely going to use this form for that part. So so the thing that we're going to need to commit to is a certain problem. So what is the keyword? How do we know if the question is asking us to do the sample size problem? So whenever you see the keyword how large, okay, so how large. And so most of the questions, they always gives us some hints in how we're going to solve them. So whenever you see the keyword how large, how many, and how big, for example, So meaning that we look for n. Okay, we look for n. We need to solve for the formulas. And what is another keyword that we need to understand is that we need to use minimum sample size. So this is another word, sample size. So we also look for n as well. So this is the thing that we need to pay attention. Okay. So this is really important that we understand that the thing that we look for n will be coming from the keyword like that. And what the question is going to give us, the questions going to gives us um, the question is going to gives us um, the error. So what does the error stand for? So the errors that we're going to have followed by the keyword margin of error. So this is the thing that we're going to have to understand. So margin of error. And also is followed by the keyword within. So whenever you see the keyword within, so that would be the error bound. Okay, it is really important because in order to identify the error correctly, usually the key an error usually the smallest number that we're going to have. I mean, the error bound cannot be big, right? It cannot be bigger than a standard deviation. It cannot be bigger than any question that we have. Smaller number usually. Um, so so this is what we need to understand. And so why is followed by the keyword within or no less than, no more than, whatever it is, because the error bound control by the how many samples that we collect. So this is a thing. So now we're gonna box this and we're gonna utilize this fact when we solve the problem. So the problem that we have from the book, this is also one of the exam two review questions. So assuming that we have a certain things, let me just copy and paste. Okay, so this is what the question looks like. So let me just make it a little bigger for that. Okay, and we're gonna cause the mail. Okay, so we're going to highlight them. So what is the keyword for that? So the question gives the standard deviation equal to 63 pages, and we also have the within. So the keyword within also represent the error. So very important when you go back to the thing that is said earlier. So whenever you see the keyword within, so that would be the error bound. So we're going to put this down as the error bound. So this is very important. So, and also another keyword that we need to look for in this case would be what the question is asking us to do. So the question will be asking us to using the keyword how large or how many, how big, or what is the minimum sample size. So this is the question that we're going to answer. So we need to look for the keyword how large. So I saw the keyword right there. Okay. So and then so we look for the n in this case. Okay, so the sigma, the standard deviation that we have is 63. Okay, so we're gonna put them down as well. So we don't really lose the information. And so the error is 20 pages. Okay, the error usually is smaller number that we have on the questions. And to achieve, we need one more thing, confidence interval. So 90% confidence interval. I'm gonna put them down right here, 8, 90% confidence interval. Oops. Okay, so this is usually given. Okay, this is usually given. So there's no doubt that the question going to give it this part. And so how can we compute that one? So the confidence interval that we have will be called a CI, and the CI that we have is 90%. Okay, and what we need to do is that we need to apply the formulas. The formula is just one single formula for that. We don't really have to do like 10 or 20 formula for that part. So the formula that we're going to use will be the E equal to the Z, one single thing, times the standard deviation over radical N. And this is, oh, I'm sorry. We cannot use that one because E is given, right? And apparently that we trying to solve for the N. I apologize for this part. I mean, you can write them down and solve for N, but it's really complicated because the questions already give us the N. I'm sorry, already give us the E. So we're not going to do it that way. We never know what it is. We have the E already. So what the point of solving it? And then we're going to look for the N equal to the Z times the standard deviation over E, and then we put the square. Okay. All right, so it's really important that we know what it is. So the standard deviation that is given by 63, and the error value that we have is 20. The only thing that we don't have would be the z-score. What is the z-score? So the z-score will be given by the table, right? So the formula package that we're going to use on it. So what is the table that we're going to have? We're going to go to table 3b. Again, that whenever we come to the z-score that we have to go to table 3b right there. So apparently that the first questions, the part A question that we have to look at the 90 confidence interval. So the 90% confidence is literally 1.645, right? So this is 90%. And then we're going to utilize that to solve this question. So we're going to take the Z of 90% would be 1.645. I don't seem to have enough space, so I'm going to erase that and write it a little bigger right there. Okay, so let me just redo this question again. So 1.645 and multiply by the standard deviation is 63, and then we take the square. Okay, so we're gonna do the square at the end. So when you do that on a calculator, you gotta be really careful. So let me just pull out a calculator and show you how to do this computation. It's super important that we know how to do so. And so the thing is, if we don't know how to use a calculator, so this is the virtual calculator, you can download it. And it's on Google, and you can get it for free. Again, that it's not something really hard calculator that we trying to use. So unless that you can use your own calculator, that is perfectly all right. So now we're gonna take open the parentheses, 1.645, right? And then you multiply by 63, correct? We multiply by 63 because we need to multiply first, and then we divide it by 20, correct? And then you close the parentheses. So you need to have the parentheses in the front. I always put them. And then after that, you're gonna hit the square. So when you hit the square, we don't take the second. Remember, when we hit the square, we just look for a little symbol right there. I'm gonna hit the square right here, and that's it. And that would be the basic one single competition that we need to do for this type of questions. And then we just hit enter. And then the answer that we got here will be 26.85. Okay. And this is the thing that we need to do. And so remember, the sample n usually the perfect number. We can't have like 26.85 sample. 2685 novel in this case, the best-selling novels. So all we need to do, we need to route up or route out. But usually that we have to route up to guarantee that the error bar cannot exceed a certain pages. In this case, we certain 20 pages, so we route up to 27. Okay, so we always have to route up for this type of questions that we only route up two things. The one would be on chapter 2, where we need to route up the chapter 2 that where we need to route of the keyword, right? Chapter 2, I believe that we route of the class word. So for this one, we have to route up the sample size. But if you don't want to round them off, that's fine. But you're gonna keep me the answer, which is 26.87. But I'm sorry, 26.85. But the answers have to be 27. Anyhow, and we're gonna go to the part B of the questions where we're going to look at 95% confidence interval. So what is a 95% confidence interval? Um, so the part B will be slightly different because we're gonna have a different z-score. Remember, the confidence determine the z-score that we're going to use. The bigger the confidence, I mean, you want to be sure about what you're doing, right? So the bigger the confidence, the bigger the z in this case. So we have 95%. So again, we're going to use table 3b to solve for that, table 3b. And similarly, that we're going to rewrite the entire question, which is the n equal to the z times the standard deviation, right? Multiply the standard deviation and divided by errors. And then we do the square right there. Okay, so in other words, again, that we're going to look for the z-score on the table 3b. Remember, for this type of question that we can't use table 4, okay, we can't use that. So the only thing that we're going to be doing, that we're going to use table number 3b to solve for that. So the 95% in this case, 95% confidence that we can check them, and the answers will be 1.96. So we can clearly see that this is 1.96 in this case. So we're going to get to open the parentheses in this case, and we're going to take 1.96. Remember that the z-score will be different depending on what confidence interval that we apply, what the question asks us to do. But we basically have the same standard deviations, which is 63, and then we have a same error bell, that'll be 20. Okay, and so the part is that we get it done. And for the type of question, just use a calculator again. So we're going to take 1.96 times 63, times 63, and divided by 20 again. And then we do the square. So in this case, we're going to do the same, pretty much the same thing. Instead of 1.645, we replace by 1.96, and then multiply by the standard deviation divided by the error, and then we do the square. So the answer that we found here will be 38.11. Okay, 38.11. So the minimum sample size that we need to take will be around 39 novel in order to restrict the error to be 20 pages as 95% confidence. So this is really important that we need to understand. So we route up to 39 in this case. All right. Oh, so we only routed for this question. Other than that, you're gonna keep the same thing. So that's pretty much a thing that we need to do for this part. And we're gonna do a few more questions, and then we're gonna go over to the exam 2 review. Remember, the exam 2 review will be on next Thursday, though, so that'll be a week from today. And make sure that we're gonna finish that part relatively, the thing that we need to do. So let me just pull out the exam 2 review, and I'll let you know what it is. So the exam 2 review for the spring, what we have right here. So you're going to try a few questions with the sample size and how we're going to deal with that. Okay, so remember, when a question asks us to construct a 90% confidence interval, that'll be the part A or part B. So in this case, it's part A because they give us the chubby, I mean the sigma. But let's say the question's asking us how large, right, of a sample. So that's absolutely the thing that we have to deal with the n. This question was the question that we just did earlier. And so 90% confidence interval, and this is the chapter 8, part 1. So we're not going to deal with that questions. And similarly, when we pick the question so now this question would be a thing that we might want to do it. So the manager of the newly opened Target store estimated the average expenditure of his customers, right? So we want to look at this question and see how we're going to proceed that. So now what the question will say will be the thing that we have right here. Let me just make it a little bigger so that we can see through what it is. Okay, so this is question 38 on the list. So I'm gonna put them down as question number 38, and I'm circle it so they can see this is the question that we worked on. So now what we need to understand, we're gonna analyze the keyword. So we need to look for n because the question is asking us find the sample size, find the appropriate sample size. So we need to look for n, okay? Okay, so we never know what the n is, but now we look at this part, the margin of error is 5 hours. So what does that gives us? So this going to gives us the error. So it's pretty obvious. So this is the error about equal to 5 hours. Okay. So this is the 5. Usually the smallest number. Remember that the error about usually the smallest number, and the standard deviations that we have here is 16. Okay. So let me just uh, draw a light right there. This is relatively um, so now we're going to have like a error bar is 5 and standard deviation is equal to 16. And what we have also the confidence interval. So why do we need the confidence interval? The confidence interval is going to help us determine the Z or the T. Okay. But for this question that we only do the Z score for the sample size. So that would be 99%. Okay, so we're gonna have all this information at hand, and all we need to do now, we need to solve for the n. What is the n? The n would be equal to the z times the standard deviations over e squared. Okay, this is the thing that we need to do, and you square them, and we're gonna get the answers that we have right there. So let's say we have 99%. In this case. So 99% will be 2.58, right? So apparently the critical value is 2.58. We're going to question gives us 99% confidence. And we're going to take 2.58, open the parentheses. We're going to take 2.58, and then we multiply by the standard deviation. What is the standard deviation? The standard deviation is 16. And then we divide it by the error bar. So the error bar that we found is 5, okay? So it should be given from the questions. The error should be given from the questions and followed by the keyword margin of error. So how do you know? This is what I pointed out. Margin of error or the keyword within, that's going to give us the error. So the error bar is E. Okay. So the thing that we're going to write them down is that we're going to put 2. We open the parentheses. We open that. We're going to take 2.5a and times the standard deviation will be 16 and divided by the error is 5, and then you close the parentheses, right? Make sure that we close it before we take the square. If we don't close them, that will be wrong. And then we hit the square right there. So we have to, you can separate them into two calculation, but that's going to be a little more complicated, right? Just hit the square right there, and then you're going to get the answers, which is 68.16. Okay, 68.16. And that's pretty much it. This is the one single calculations problem, 68.16. And then we just route up to 69. Okay, we route up to 69. That's it. So we finished the questions, generally relatively easy for that part. So now we're going to go to try another question and see. Let me pick the question with the n. This is not the n. This is 90%. This is chapter A, part B. You have to use the T. This one, construct a 99% confidence interval. This is have to do with the T. We're not going to deal with the n. So now we look at this question. What is the minimum sample size? Hold on a second, right? And so this one is literally the thing that we need to do right here. So whenever I see the keyword, what is the minimum sample size? So the question is asking to look for the n. So apparently that we need to solve for n in this case. So and what we have to do, would be, again, that we're going to pose the questions first. We're going to make it bigger so that I can see them, what it is. Okay, and then we're going to put down what the questions is 44, and we're going to solve for that. So the question's going to gives us what? The question gives us 95% confidence interval. So this will be the CI, right? And this is given. And we also have the standard deviations equal to 8. This is also given. And what else? We also have the margin of error. So the margin of error also followed by the keyword within. This is absolutely the E. This is absolutely the E. Okay. So, and now we're going to write them down. So the E in this case is 1.5, right? So if the question gives us the same unit, the million, so we just basically take 1.5 and that's it. So the answers have to be in terms of the million. They're going to cancel this out whenever we divide them. So don't worry about the million to convert to 1.1500000. We don't necessarily have to do that. The standard deviation equal to 8, right? So that's pretty much the thing. I forgot to put them down. So this is 2.5. You have to look for confidence, the z-score. Okay, so the z of 99%, I would say 0.99 right there. I just want to make sure that we know what it is. So that would be 2.58. Okay, 2.58. To be exact, that would be 2.576 and more, but 2.58 should be all right. We round up to 2 decimal number. Okay. So the confidence interval that we have is 99, 95%. Okay. So the confidence is 95%. So this is a thing. Okay. So generally now after that, we're going to deal with the errors. After that, we're going to solve for n. So the n will be what? The n equal to the z times the standard deviations over radical over e. So, and the z, so what is the z of 95%? So the z of 95% that we can check them, right? So we're gonna check it on the form of the package. 95% is 1.96, so we can literally check that right here. So 95% on table number 3B, so that'd be 1.96. I'm gonna use this number on it, so 1.96. Okay, this is really important. And then we're going to take 1.96. Okay, 1.96. Let me just cost them out. 1.96 times the standard deviations, which is 8, right? So we multiply by 8. And then we divide it by the error bound. So the error bound is 1.5. Remember, the error is always be the smallest number that we divide, right? So this is the number that we found on the chart. This doesn't count. But the thing is, the standard deviation very likely to be bigger than the error. So we don't want the error to be really, really challenging to the standard deviations. So usually the error bar should be the smallest number. So we have given by the error to be 1.5 million. So this is how many samples do we collect for the hash fund for the earning for that part. And I'm going to use the calculator for that. And then we're going to open the parentheses. So we're going to take 1.96 and we multiply by 8 and then we divide it by 1.5. We close parentheses, just square them, we square this, and then we're going to get the answers correctly. So that would be 109.27. Okay. Okay. So the required sampling that we need to collect will be 109.27. So let me just write them down so that's going to be a little bit easier. So 109.27. And then we can write up to 110, okay? So usually this chapter that we need to write up for the sample size, so that we want to make sure that the bow, the error does not exceed 1.5. Okay, so that's pretty much the thing. And then we write up to 110. And then we just rewrite them right here. So this is the 110 for that part. And that's pretty much it that we need to do. So we can go over a certain questions that we have learned earlier about the sample size. And let's go one more question before we go back to the topic for that part. So we see how many students, right? So if the question gives us how many students, then we have to look for n. So for this type of questions that we can do it one here, the n part would be this one. So we're going to analyze this again. So what we have to be doing will be the following. Okay, first, that we understand the questions gives us the keyword. So what is the keyword for that? The keyword is within 18, right? So this is the error. So you need to wonder where this number coming from and what kind of perspective that we have to look for. So the E would be 18. This is the error browse, 100%. Okay, 100% E would be 18. Okay, so what question is that? Let me just take a look at that. That is question number 45. And I'm going to point that right here, 45. And this is what we need to do. Okay, so the error bar is given. So let me just erase that. Let me just write them down. It's easier. So the E equal to 18. And what else do we know? The confidence interval. And we also know the standard deviation is 48, right? So standard deviations is 48. And then we also have a confidence interval is 90%. So we can literally check that, right? The standard deviation and the confidence interval is 48. The standard deviation is 90%. So we're going to put them down. The CI equal to 90%. So do we have to write about the information? The answer is not necessary, but it basically helps us to understand what kind of problem that we need to do, right? And now we need to look for the n. So how do we know that the question asks us to look for the n? So we're going to analyze that. How many students, right? How many students? So we need to solve for n, right? So it's the keyword. Generally, this is what we have. How many students? So we need to look for n. What is the n? Okay, so the questions again that we're going to do, the n equal to the z times the standard deviation over e squared. It's always be like that. So if you ask me, do we have to memorize this formula? The answer is absolutely no. We have the following package on the second page of chapter 8, and this is all we need to look at. So this is the sampling. So the first one, the mean equal the n equal to the z times standard deviations over e squared. Okay, so the z is based upon the confidence interval in this case. Which called a critical. The c is basically mean the critical values based upon the confidence interval that we have. Let me just write a little better. So this one is over e squared. Okay, so and then after that, we just look at, so 90% is 1.645 for the z-score. We can check them out on table number 3b again. In this case, we have 90% is 1.645. You can clearly see that this is 1.645. And then we can utilize this to take 1.645 and then we multiply by the standard deviation. So the standard deviation that is given by 48, right? And the E would be pretty much the smallest number that we have here. So the E is 18. So we divide it by 18. And then you square them. And that's pretty much it. So the final answers that should be computed, we're going to take 1.645 time, no, I have to open the parentheses, I apologize. So 1.645 times 48 and divided by 18. And then we take the square in this case. So we're going to get the answers, which is 19.24. Okay. So we need at least 19.24 student. So it seems we cannot keep the students at 19.24. That doesn't make any sense. So we're going to round up to 20. Okay, so that's pretty much the thing that we need to do. We round up to 20. Okay, so that's pretty much the thing that we need to do for that part. And so now we can try to go over a certain question. Again, if you want to ask me the question, make sure that you unmute yourself a little bit, and before you ask me the questions. Okay, so again, that it's really important that you can ask me what kind of questions that you have for this kind of chapter, and then we can go over it. Okay, so again, whenever the questions gives us like that, for example, I look at question number 46. What part of chapter 8 that we need to solve given by this more questions? Okay, so let's say we going to solve for these questions. It seems to be a little bit different from what we learned because the step that we have right here. Okay. So now I just posed the question. So what type of question is that? 46. All right. So I put them down as question number 46. It's really important that we know what kind of chapter. When the question gives us the S, when a question gives us the S, the standard deviation S, when the question gives us that, this always be chapter 8 part 2 because we have to do the T. Remember that when a question gives us the S, we always have to do the T. And also the question going to ask us to construct a 95% confidence. So we have to look for first step, we look for the E, and second step, we plug into the X bar minus the E, X bar plus the E. The questions regarding looking for the sample size. So let's say how many students look for N, the question doesn't give us the X bar, remember, it doesn't give us the average, okay? So in this question, this guy is 7.64. So what is that? So this is the mean time spending studying for the exam is 7.64. So this will be the X bar, okay? This will be the X bar equal to 7.64. So this question gives us the X bar. Question number 45 doesn't give us that. We don't need X bar to look for the N. Okay, so, but the question also gives us the sample of 30 undergraduates. So this question gives us the N equal to 30. So remember that we're gonna utilize all the information before we can know what type of question that we do. So this is literally just the question that we just did on Tuesday. So this is N equal to 30. Okay, and so now we're going to look for, let me just rewrite them. So now we're gonna look for the standard deviations S, and in this case, S equal to 3.8 hour. Okay, so the confidence interval in these questions that we can check, the confidence interval will be equal to 95%. So remember, when the question gives us the S, then we cannot do the z, we have to do the t, okay? And 95%, so we need to convert to 0.95, making sure that we're going to do so. Let me just rewrite them, 0.95. Okay, so whenever the question gives us the s, then we have to do the t, 100%. So meaning that we need to first step, we look for the degree of freedom, so that'll be n-1, the df. This is very important so they can look at chart correctly. So that'll be 30 minus 1 and 29. Because we have 30 sample, we take away 1, you get 29. And after that, we're going to look for the error bell. So the E would be the T times S over radical N, right? So this is a thing that we learn from it. And so what is the T part? So the T, we need to look for the chart. So the T, we have to go to table number 3. Sorry, table 4. I apologize for that. Okay, so we're gonna go to table 4. So how can we read the t-score? Again, that we're gonna go to table number 4. And what is the degree of freedom? So the df will be on this column, the confidence interval will be on this row, and then we're gonna read that. So the confidence interval that question gives is 95%. The degree of freedom is 29. So we're gonna go all the way down to 95 and 29 right there. So I'm going to make it a little smaller. You can see through the confidence interval right there. So we're going to go to 29, and this is 95%. So you can clearly see that. So 95 and 29. So the intersection for that is 2.045. Okay, 2.045. So make it 90. Yeah, we can still see them. So this is the confidence interval, which is 95%. And with the degree of freedom is 29, so we can check that. That would be 2.045. So we're going to take that 2.045, and then we multiply by the S, by the sample standard deviations, in this case, again, the 3.8. So whenever the question gives a snack, right, so it has to be the T. So you have to drink tea with a snack, right? So apparently this is the thing that we need to know, and then we divide up a radical n. So the n, remember, when we look at the chart, they have to go to 29. We have to go to 29 because the degree of freedom is n-1. But when you divide, we gotta be really careful. So when we divide, we have to divide, but n is 30, n is not 29. So when you plug in the value, you gotta be making sure that the n in this case is radical 30. Okay, so again, when you look at the chart, for the t, is we have to go to 29. So this is what we found on the chart, right? And so we go all the way down to 29. Okay, and then you look at 0.95. We go to 0.95, and then we take the intersection between these two. And then we're gonna get the answer is 2.045. Correct? However, when you divide it by radical n, so remember, n is not 29. Let me just repeat that again, because so many people who, not only one person, like maybe 10 of us on the exam just divide up by radical 29 for some reason. Go, we have 30 students, so n is 30, okay? So now we're gonna do this calculation on the calculator as well. So the calculation that we need to do should be 2.045 times 3.8 and divided by is radical. So how can we take those radical? Now it's different from the square, right? You can't just hit the square. You don't get the radical term. So you're gonna get the something square. So in order to get the radical, you're gonna hit the second and then the square root, right? And then this is what we have. Second like square. and you put out 30, we close parentheses, and then we hit enter, and then the answer for that is 1.418 or 1.42. Doesn't matter which one, 1.41. Okay, so you're gonna get that part. You write them down 1.42. Okay. So after we get the answers for the error bell would be 1.42, and then we go into compute x bar minus the mean, x bar at the mean. This is what we need to do, right? So again, that this type of question is actually much harder than looking for the sample size for question number 45, because you can see that it's just one way, one calculation. We need at least 20 student for the SAT score, and that's it. For this part, you have to do two calculations. The first, you need to compute the error bell, and the second, we need to look for the range for the population mean. So that'd be x bar minus the error, x bar plus the error. So remember, the mean should be bounded between these two values, right? So some of you might be wondering, can we write something like we have from the formula sheet? Like that. It's basically the same thing. So this is x bar minus the error, and this x bar plus the error. So the mean bounded between these two numbers. So you can see that we have two inequality, two less than sign that coming along with that. It's basically the same thing to tells us that the mean is basically bounded by these two numbers is generally a thing. So instead of we doing that, we draw out the interval. So this is basically look a little easy for us. And so again, that we're gonna do this, and then we're gonna take x bar that we have, know that the x bar is given. So we haven't touched this number. So the x bar have to be given whenever the question asks us to construct 95% confidence interval. So we haven't really touched the number 7.64. So meaning now this time we're going to use it. So we're going to take 7.64 and minus the error value is 1.42. And same thing, we're going to take 7.64 and plus 1.42. And then we just do this calculation for that part, and we can say 7.64 minus 1.42. And then we got the answer 6.22. And similarly that we go into, let me just make it a little bigger. So, and then after that, we just compute it. So 7.64 minus 1.42, and then we take 7.64 plus 1.42. They're basically two calculations for that, 6.22 and 9.06. Okay, so let me just make it a little 6.22 and 9.06. So this is the case that we're going to have for the range for the population. So what is the conclusion that we need to make? The conclusion is going to tell us that, make, okay, so I think, let me just try to get to the part. Hold on a second. So, okay. Now we can just literally check them for that part. Okay. So I think I'm making mistakes right here. And now we just draw the thing that we have right here. Okay, so this is the bound for the mean. It should be bounded between 6.22 and 9.06. So what does that mean? So this basically means that the as 95% confidence, so I can basically tell you that I'm 95% sure that the mean time that the students spend for the final exam taking psychology, basically around 6 to 9 hours, right? 6.22 hours and 9.06 hours. So this is the thing that we can conclude. Okay, so this is again when we do with that, we can see that the S, then we have to do with the T, and then we need to solve for the error first. We need to compute the error, and then we compute x bar minus the error, and x bar you add the error. So when the question gives us the N, so that we have to do it the Z times the standard deviations over E. So remember, this question, we don't solve for the error bound, okay? Because the question doesn't give us the X bar. We don't need the X bar for that, right? And the question asks us to look for the N by the keyword, how many students, and so on and so forth. So that will be the things that we need to pay a little more attention for that, okay? So now let's go to another questions when it comes to the Z um, and so on and so forth. And then we, um, when do we have to deal with the Z? So it's very straightforward. The question gives us sigma, then we have to deal with the Z score. Whenever it gives us the S, then we have to deal with the T. Similarly, when the question gives us that the standard deviations, the sigma equal 28, and the question asks us to look for 90% confidence interval. So in this question that we have to look for the E equal to the Z times sigma over radical N. So it's always be like that. Okay, so all of that is basically about chapter 8. So what do we have to do for the exam 2 review? So let me just point it out real quick for that part. So the exam 2 basically going to cover a certain topic like that. So exam 2 review. So how many topics do we need to go through? Not so many, but at least that we need to follow a certain things. Okay, so chapter 5 will be the last part of it. So we need to know how to compute the combinations and permutations. Okay, so combinations and factorial is just the permutations and factorial. Okay, so this is the thing that we need to do, and I can just write them down on here, so that's gonna be a little easier to look for. So let me say exam 2 review. Okay, and so again, the first part that we need to do, the first will be on chapter 5. And so what is chapter 5 that we need to deal with? The chapter 5 that we need to deal with combinations, factorials, right? And combinations and permutation. So how are we going to deal with that? So generally, so let's say we're going to take, what is the 5 factorial in this case? I might just give you a certain question. Let's say 5 factorial will be 5. You're going to take 5 times 4 times 3 times 2 times 1. And then we do it on a calculator. We're going to take 5, you know, it's 120, but you can take 5 times 4 times 3 times 2 times 1, and then finish that. So that'll be 120. Okay, so 120 will be 5 factorial. So this is the thing that we need to do, right? And clear. Okay. All right. And now, so I want to deal with like let's say 7 factorial. So I can do 7 factorial. So 7 factorial that we can check them. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. I mean, 1 is not necessary, but we just need to write them down. 7 times 6 times 5 times 4 times 3 times 2 times 1. So that would be 5,040, right? So this is the thing that we need to deal with for the factorial. Okay, so how are we going to deal with the permutations? So the permutation, they literally going to give us the p, for example. They're going to ask us to do like 20, and then we pick 3. Okay, so what should we do for this type of questions? So 20 will be the first starting number, so we're going to start from 20, right? And then how many number do we need to multiply? So since we have 3 numbers, we pick 3 of them, so we multiply by 20 times 19 times 18. Okay, so that's will be the thing that we need to do. So we do it on a calculator, 20 times 19 times 18. So the answer for that is 6,840. Okay, so how can we interpret that? So remember that. So we're gonna take this is the big number we call n, right? And this is we pick r. Okay, so how many numbers should we pick? So you need to pick 3 of them. So multiply by 3 numbers. We started with the number that we have on the end. So we're gonna pick 3 of them. Correct? So this is pick 3. We're gonna put them down as pick 3. So we can understand that this is what we need to do. Okay, so let me just give you another questions regarding the permutation. So there will be another way that we can write them down. Instead of putting down the P20 pick 3, the question can also give us P of, let's say, 15 and pick 2. So we can also put them down like that on the questions. Okay, so now we only pick 2 numbers for that. We're not going to pick 3, right? So the first starting number will be 15. Oops. The starting number will be the 15. And the second number would be 14. So we're gonna take 15 times 14, right? We pick 2 of them. So the final answer for that would take 15 times 14, and the answer is 210. That's basically a thing. So 210. So that'd be the final answers for that part. So again, now we're going to pick 2 of them instead of pick 3. Okay, so this is what we have for the permutation. So the combination will be slightly harder from what we learned, and the combinations would be we use the C to represent the combinations. Okay, so the combination that we have a C, open the parenthesis. For example, we pick 10, pick 3 is different, right? So in this case, the n is 10. The r is 3. Okay, so so what's going on for this part is it's slightly different. So in other words, we have 3 numbers, and we need to multiply by 3 numbers. So on top of it, we need to do 10 times 9 times 8. We do the same thing because we need to pick 3 of them. Okay, but the order doesn't matter. So we're gonna put we have to divide them. So remember, we only divide when it comes to the combination. So we divide it by 3 factorial. We pick 3 of them. So we don't count the order, right? So similarly, that we're gonna do the same thing. That would be 10 times 9 times 8. And so 3 factorial is not 3. 3 factorial is 6. So we divide it by 6. Okay. This is very important. So we're going to do them now. So 3 factorial is 6. Okay. So for those of you who ask me why 3 factorial is 6, 3 factorial would be 3 times 2 times 1. So that will be 6. We equal to 6. So we do the calculator. We'll take 10 times 9 times 8 over 6. no, 10 times 9 times 8 over 6, and then got the answers, which is 120 as well. Okay, and so usually that we don't have this, and so the answer is 120. Okay, so that's pretty much a thing. And also, if we deal with, remember that if that comes to the permutation, if 10 pick 3, then take 10 times 9 times 8, that's it. But for the combinations that we need to divide by 3 factorial, the permutations, we don't divide them, right? So let me try to do another example in different fractions. The question might be writing down in terms of like a C. I mean, there are a lot of way of writing it down. It's not only the way that we have. It can be C, and then we can write 20. I mean, the 100 picture, for example. So we're gonna go over this again. So 100, and then we pick 2, right? So what should we do for that part? So how many do we pick? So we pick 2 of them. So we start from 100, right? Pick 1. And now pick another one, so 99. So pick 2 of them, okay? So 1 and 2. So we can clearly see that 100 times 99, so we pick 2 of them. And then we divide it by 2 factorials, okay? 2 factorials 2. But just want to make sure that we do it properly. So we write them down 2 factorial, okay? So we're going to take, so 2 factorial is 2, so that'd be 100 times 99. But 3 factorial is not 3, 3 factorial is 6. Just want to make sure that we do it properly. So 100 times 99 over 2. And then you're going to get the answers. That'll be 4,950. So the thing that we're going to have here will be 4,950. Okay. All right. So remember, 2 factorial is 2, but 3 factorial is not 3. 4 factorial is not 4. 4 factorial is 24, and so on and so forth. Okay. So we can try another example so we can try this combinations of let's say 48 and I pick 46. Okay, why can I write them down? And I pick 46. Okay, so that will be a little different. So we can't just do so many samples for that part, right? So all we need to do in this case, that we're going to take 48 minus 46. So we're going to take 48.
2.
That'll be 2, right? So we subtract that, you're going to get 2. So that basically the same thing. We pick 48 picture. Yeah. And so in other words, and then we're going to do like 48 times 47. So we pick 2 of them, right? So that would be 48 times 47. And then we divide it by 2 factorial. So we divide it by 2 factorial. And so the answers for that part would be 2 factorial 2. We do the math in this case, so we do the calculator. So 48 times 47. And we divide it by 2. And the answer for that is 112A. And that'll be the things. So I'll put down the answers right here. Will be 112A. So that will be it. That will be the thing that we need to do for the combinations, permutation, and factorial. Okay, so that will be the slightly a small part of chapter 5 that we need to go through it. And now we're going to go to chapter 6. So chapter 6 is really a big chapter where we're going to deal with the binomial, right? binomial distributions. So we need to go for N, P, and R. So they need to be followed by the step N, P, and R. So why it is so important? And because of the fact that if we don't look for the N first, we're gonna get the wrong box. We don't look for the P, then we're gonna get the wrong column. So the box needs to identify correctly first. And then after that, we're gonna look for the P and look for the R. So finally, okay, so what kind of question will be on chapter 6? We're gonna look for, certain questions. I think I gave this question on the quiz or something like that. I forgot it. Okay, let me just try a few questions and see what it is. Yeah, we can try this question again. I think we did this question, but let's do them again. Okay, so let me just highlight this and, so what the question will be on it, what type of information do we need? So how do you know it is on the binomial problem? So I never told you that, okay, this is chapter 6, this is why we need to use table 2 and the binomial, okay? The questions at the very beginning going to give us N and P, okay? Very beginning of questions, of the questions gives it gives N and P. So the N always in terms of percentage or the decimal number. I'm sorry, N in terms of the whole number, right? And the P is literally in terms of the percentage, or usually decimal number. But the question very likely to be giving us percentage, and they can see that. So this is what the N looks like, and then of course the question going to ask us, hey, what is the probability? You need to figure out what is the probability for that. So now I can highlight this. So 40%. So um, that would be the oops. Would be the P. So let me just do them very quick for that part. 40%. Okay, and so we have a sample of 8. So this is the N for that part. Oops.
What number is this, Professor?
I'm sorry?
What number?
What number on the exams? I was saying question number 40. Yeah, question number 40 that we have on the exam 2 review. Remember, all of these questions that we're working on were exam 2 review. So this is question number 40.
Okay, thank
Yeah, it's 40%. It's 40, and so I was scared. And so now, why do I always have something like that? So I don't understand. Okay. Oh, now, okay. So again, chapter 6 that we have to do with table 2, it's very important that we going to use table 2 for that reason. Maybe my mouse is acting up or something like that. Okay, so this is table 2. Okay, yeah, table 2. Okay, so again, that we need to identify NPR in this case, and then we put them down. So now since we're using this part, and so remember N and P will be given for this question. So now we're going to use the table, the chart, right? And so the chart that we're going to look for is table 2. So what is the N? N is 8, so we need to look for 8, right? And P is, what is the P? It's 0.4. Do we agree? So the P in this case is 40%, so we have to be 0.4. So and now which column that we have to use? So now in this case, I'm going to copy and paste to this part. And so the column that we need to use will be that one. Okay, so this is the entire column that we need to use. Okay, I want to copy this and paste it, right? And so I'm going to paste this right here. All right. So this is the entire column that we need to look at that. Okay. And so we also copy the R. So R equal to 0. And let me just do that. So R here. Oops. And let me just copy back to this and then connect them. Right, so you can literally check that the question's asking us to look for the probability of at least 7. So we need to understand the key word for that part, at least, right? So so let me just put them down. At least 7 mean what? Means 7 or more, right? So 7, 8, whatever it is, 8 out of 10, but 7 or more. So you can literally check that the two things that we need to box will be these two probability, correct? So that will be corresponding to the question that we're looking for. Do we agree? So the first part A of the question, so we want to figure out, hey, what is the probability that at least 7? So at least 7, meaning that we need to start from 7, and then we add the probability of 8. So R equal to 7, R equal to 8, and then we're going to get 0.008 plus 0.001, so we're going to get 0.009. Okay, and that's pretty much the thing that we need to do on the first part of the questions. And now we're going to go to the part B of the question. What is the part B of the question? So the part B of the question, so what is the standard deviation? So now we're going to go to the chart and we're going to go back to the first page of that. So this is the standard deviation, the mean and standard deviations. Okay, I'm going to copy this and post it. It's right here, just in case that we're going to use this part again. So those two would be the thing that we need to use, right? And the mean and standard deviation that we need to know how to compute them on the exams. So I'm going to copy and paste right there. Okay, so this is the formulas, chapter 6 formulas. Okay, so I'm going to box them, making sure that we continue using that on this part. Okay, so now we so this is chapter 6. Okay, so again, this is table 2. Just let me indicate that thing that we don't actually get it wrong. So this is table 2, and this is all chapter 6. Are we good? Yeah. So now the part B, the question. So we're gonna start with the part B.
Wait, Professor, what you said we need to find N, then P, then R, but what's N? Which one is N?
N is A.
Is A, and P is
P is 0.4.
okay.
Is A. Okay. And P is 0.4. P is 0.4. Okay, I forgot to put them down. So I'm going a little too fast for that part. Okay, so P is 0.4. And so that's the reason why we have this is N equal to 8. Okay, N equal to 8. Okay, so we have a sample of 8 workers. So now we're gonna do the part B right there. So the part B, the mean equal to, so we can see that the formula of the mean equal to N times P. Correct? So the N in this case was 8 And the P that we have is 0.4. And then we just compute this. So the fact is we're going to take 8 times 0.4. We're going to calculate 8 times 0.4. We're going to get the answer is 3.2, right? So the answer would be 3.2. Okay, so let me just rewrite them. 8 times 0.4 using the letter is easier. So I take 8 times 0.4. And we're going to get 3.2. So what are the standard deviations? So the standard deviation would be, we can check the formula for that. Oops. Okay, so the standard deviations that we have is radical of N PQ, right? Okay, so what is the N in this case? So the N is 8, and then the P is 0.4, and then Q is 1 minus P, right? So we're gonna take Q equal to 1 minus P. I mean, the change that people get the insurance through the employees was 0.4, so the change that they do not get insurance through the employer, so it's 0.6. So we can just take that. So the Q equal to 1 minus 0.4, and we can get this is 0.6. And then so we're going to take the standard deviation, so that'd be N, oops, so that'll be 8 times 0.4 times 0.6. So that's pretty much a thing that we need to do. Okay, so now we're going to use a calculator for that part. We're going to take the square root of 8 times 0.4 times 0.6, and then close the parentheses. And then we're going to remember that we have to hit the square for that part, right? And so we're going to get the answers is 1.3856. Okay, so 1.38. Oops. So that's pretty much it. I think my mouse is not feeling good. So 1.38. So that will be the final answers for that part. Okay. So that's it. So that would be question number 40. And then of course that we're gonna go to question number and another question for that later on. Okay. So that's it for today. And if you have any questions, let me know. And when we come back on Tuesday, there will be another review. And then we pretty much going to review again on chapter 6, chapter 7. I mean, chapter 8, we just did that. Chapter 8, we just do 2 part of it right there. And so now we just literally need to do for chapter 7 and the thing that we have right there. Okay. So are we good? And yeah, chapter 6, I haven't really posted any video yet, but I will make the video.
I'm totally lost in chapter 6 because
Chapter 6, yeah. So this is on table 2, and the very beginning, that how do you know it is on chapter 6? The chapter 6 is basically gives us the n, and then the p will be the percentage, the n will be the whole number, right? So the p can be identified through the questions, and also with the n, p, that we can see that the p is 0.4, and then the n is 8. So the first step that we have to go to the n equal to 8 first, right? And then we go to 0.4, correct? So this is the column that we need to use. So this is the entire column. This is what I copy and paste for that part, right? This is the entire column. You can check that. Okay.
Mhm.
So, and after that, we're gonna look at the probably of at least 7. So we have to look at for the R. So how do you know how can we get the R? The R should be given from the questions. Okay, so the R that we can check is literally 7. So we want you to find at least 7. So at least 7 meaning what? At least 7 mean that we look for 7 or more. So this is the thing that we have right there, right?
Yes.
So at least 7 will be 7 or more. So we're going to count 7 or 8. So we can't go more than 8. So we're going to add up 7 and 8 in this case given by the chart. So the chart is on table 2. And then just add 0.08 and 0.001. And then got the answer is 0.009. This is basically the thing that we have to look at the chart and pretty much that you have to add and add the probability together.
Okay.
And after that, we're going to look for the expected value. So the expected value will be n times p. This is what we have for the formulas. The mean equal to n times p. The standard deviation would be the sigma equal to the radical of n times p times q. So these two formulas basically given from the chart, and then we can check them right there. So this is the table that we need to use for standard deviation. Okay. And after that, we're going to look for the n is 8 and p is 0.4, and we get the answer is 3.2. And finally, we look for the standard deviation. So what is the standard deviation? The standard deviation will be the radical of npq, right? So that'll be the radical of 8 times 0.4 and times 0.6.
Okay.
Okay, and then we take the square for that. We gotta get the answers, which is 1.38.
Okay.
Yeah. Okay, you can take the square root. Remember, we're going to do the square root of 8 times 0.4. Square root of 8 times 0.4 and 0.6. We close parentheses and get the answers is 1.385. Okay?
Mhm.
Okay, so far so good for today. And then I'm going to post this part. We're going to continue working on the exam 2 review on Tuesday before we have the exam next Thursday. Okay. All right. So this is chapter 6. And then, of course, that we come back, we're going to do one question of chapter 6 again. So just remind you that we don't forget the things. And after that, we're going to move to chapter 7, will be the main chapter that we have. And then we're going to review chapter 8 a little bit again. And then we're going to call it a day on Tuesday. Okay, so far so good. I hope you enjoy your weekend. Stay safe, stay healthy, and I'll see you guys all on Tuesday.
Okay. Bye, Professor.
Okay,
Bye.
bye, Professor.